So the problem says determine the amount of money you would have in 10 years, so that's my time, if you deposit $5,000 in an account that has an annual interest rate of 3.75% and is compounded. A is quarterly, B is monthly, C is continuously. So a couple things. What I normally like to do is just underline my numbers and then decide what variable they go with. So 10 years is time. $5,000, that's my principal amount. That's my initial amount. My rate is going to be 0.0375 because I'm putting it into a decimal. And so the formula would be A equals 5,000, 1 plus, it's R over N, so 0.0375. Compounded quarterly, N would be 4 times a year. And then to the 4 times 10 to the 40th power. And you can just type that in your calculator. Use the parentheses, or you can do the inside. But you should end up getting, you can test this on your calculator. Make sure that it works. $7,262.26. If I did the same thing for monthly, everything stays the same. But now I'm going to put 12 here. Not 4, sorry. 12 times 10. And you should get 7,270.70. If I'm compounding continuously, I'm going to use this formula, PERT. So A equals 5,000. You keep the E there. Remember, E is a constant. To the R times T. So 0.0375 times 10. And you should get 7,274.96. So you'll notice there is a slight increase with the more that it's being compounded. It's not significant though, especially after 10 years. You would think there would be a bigger gap, but not always the best to compound continuously. So for number 5, if you deposit $15,000 in an account that has an interest rate of 5.5% compounded monthly, so N equals 4. Nope, N equals 12, sorry. Can't do math. How long will it take for you to have $40,000? So I'm going to set up my original equation, which is 15,000, 1 plus 0.055 over 12 to the 12 times T. And then it's asking me how long it will take to get to 40,000. So I'm going to set that equal to 40,000. And I'm solving for time. Now we're going to solve it kind of like we did in the last examples. I'm going to divide by 15,000 first. So you end up getting 2.67 equals 1 plus 0.055 over 12 to the 12t. I'm going to go ahead and work this out in the parentheses and get a decimal. So if you want to plug that into your calculator, you end up getting 2.67 equals 1.00458 to the 12t. Now I can put this in exponential or in logarithmic form. If you want to write it where these two are switched, like 1.00458 to the 12t equals 2.67, then you can do that as well. Sometimes it's easier. Now I'm going to put it in log form. So the 1.00458 comes down to the 2.67 equals 12t. Divide each side by 12. And when you plug that into your calculator, you should get 17.874 years. So the only difference is now you're having to divide by 12 at the end, or divide by however much it's compounded by. But other than that, the steps are exactly the same. Okay, number 6, it says, what interest rate would you need? So now we're solving for R. R question mark. If you were going to deposit $5,000 in an account, so that's my initial amount, and you wanted to have $7,500 in 10 years, and it was compounded continuously. So we're using the PERT equation. I'm solving for R. I'm going to plug in everything else that I know. I know I want to end up with 7,500. I know I want to start with 5,000. 5. E, I don't know my R, but I do know that my time is 10 years. So I'm going to actually write that as 10R. So I like my number first and then my variable. Then I'm going to solve it the exact same way. So I divide each side by 5,000. So you get 1.5 equals E to the 10R. Then I'm going to put it in logarithmic form. If you want to write E to the 10R equals 1.5, that might help. When I put it in logarithmic form, the E comes down and I have log base E, but I'm going to write that as ln of 1.5 equals 10R. So how I got this is I just wrote log base E of 1.5. But I skipped a step and I just called this ln because it's the same thing. Then I divide each side by 10. And R you should get 0.0405, or we could say 4.05%. Next example, it says in 2000 the average price for a football ticket for the Dallas Cowboys game was $48.28. During the next 4 years, the price increased an average of 6% each year. Develop an appropriate model. So it's not talking about any compounding, so it's just going to be like the 1 plus r minus r to the t power. So I'm starting out at 48.28. Then I'm increasing 6% each year, so 1 plus 0.06 to the t power. Estimate the year when the average price was $60. So now I'm going to set it equal to 60. Divide each side by 60, or it's not by 60, by 48.28. You get 1.24 equals 1.06 to the t power. Now change to logarithmic form. Log base 1.06 of 1.24 equals t. Plug that in your calculator. You get t equals 3.73. But it's saying estimate the year. So if it started at 2000, going to add 3 years, 3.73 years. So I reached $60 in 2003. Probably towards the end of 2003, but it hadn't reached 2004 yet. You can say years here. C, determine the minimum and maximum values of the domain that are pertinent to this situation. So it's saying that this only occurred for the next 4 years. So it occurred in 2000. So in 2000, whenever it's the year 2000, then my price was $48.28. So that's my minimum. That's where it started. My maximum would be in 2004, which would be when I plug in 4 for t to the 4th power. So if you do that on your calculator, you end up getting 60.95. That would be my maximum. So my domain is 48.28 to 60.95. Okay, last example, it says the Metroplex has a population of 4.5 million in 2000. The annual growth factor was 1.05. Anytime it says growth factor, that just means that it's increasing by and then the 0.05 means 5%. So every year it's increasing by 5%. So when I create my equation, if it gives you the growth factor, then you don't have to do the 1 plus. You would just say f of t equals 4.5 million, 1.05 to the t power. So with that, if it gives you the growth factor, you just put that in parentheses. It's the same thing as saying it's increasing by 5% every year. So whatever is in parentheses is considered your growth factor. What is the projected population in 2010? That's when t equals 10, because it starts in 2000. So f of 10 equals 4.5, 1.05 to the 10th power. If you plug that in your calculator, you should get 7.33, and that would be million. What is the annual rate of increase? Well, if my growth factor is 1.05, my rate of increase would be 5%, or you could say 0.05. In what year will the population exceed 13 million? So I'm going to set the left side of the equation equal to 13. Then solve for t. So divide each side by 4.5. 2.89 equals 1.05 to the t. Put it in log form. T equals 21.74. So if it started in 2000, 21 years, about 2021. Then E says, how long will it take the population to double? So if it starts at 4.5 million, doubling would be 9 million. Divide by 4.5, so 2 equals 1.05 to the t. Put it in log form. And you get t equals 14.21, which is about 20